Now we must find the nature of the roots of a quadratic equation. Now, you remember that this quadratic formula, everyone remembers this at this point? Well, we're concerned with this part, this plus minus under root b square minus 4ac. This part is what will give you two values for x. One will be positive and one will be negative. So, the nature of those roots will depend on b square minus 4ac, this term, and it will be called a discriminant. So from now on, we'll refer to b square minus 4ac as the discriminant. So in the first case, if the discriminant is equal to 0, then the roots will obviously be minus b over 2a, since this entire portion becomes 0, and you're left with this b square minus b over 2a. So the roots will be minus b over 2a twice. They will be repeated. This minus b over 2a will be repeated as a quadratic equation has two roots. So the roots over here will be real, as obviously 0 is a real number. This entire portion will give you a real number, and they will also be repeated, and they will be equal. They will be equal because b square minus 4ac is equal to 0. They will be real because minus b over 2a is obviously a real number. Now, in case 2, the discriminant is less than 0. So, the under root b square minus 4ac will be imaginary, as b square minus 4ac is a negative number, less than 0. So, the roots are complex or imaginary, and they will be distinct and unequal. They will be distinct and unequal because this is not equal. So b square minus 4ac is not equal to 0. And they will be complex and imaginary because the discriminant is less than 0. Similarly, in the third case, well, not similarly, but the concept is similar. This b square minus 4ac, the discriminant, is greater than 0. So the under root b square minus 4ac will be real, as b square minus 4ac is a positive number greater than 0. So the roots are real and distinct and unequal. Why are they distinct and unequal? Because it is not equal to 0. The discriminant is not equal to 0. And what you must also remember is that if b square minus 4ac is a perfect square, then this under root b square minus 4ac will be rational, otherwise it will be irrational. The roots will be rational if this b square minus 4ac is a perfect square, otherwise irrational. So let's just say we're given an equation like this one here, x square plus 4x plus 2 is equal to 0. Now, b square minus 4ac, we have to find the nature of the roots of this particular equation. So b square minus 4ac is equal to 4 square minus 4 into 1 into 2, which becomes 16 minus 8, which is equal to 8. 8 is not a perfect square of any number. So if you do under root 8, it will just become under root 8. It's not a perfect square of any number. So the roots of this equation, the roots are, well, under root 8 is a positive number. So b square minus 4ac is basically b square minus 4ac is equal to under root 8, which is basically greater than 0. So the roots are real. This is case 3. They are real, they are unequal or distinct, and lastly, they are irrational, as under root 8, as basically 8 is not a perfect square. So that's how you do it.